Hey guys, so this has been running for a couple days now. Here's the output voltage now. It started at, from the beginning of the previous video, it started at 57.43. On this one was 13.34, I think. Not 100% sure on that, but somewhere around there. So here's the analog current. There's the scope shot, starting at 333 hertz. When I stop the rotor and just hold it in the on position, it's at 333 hertz. Frequency of the rotor's been steady, 57, 58. Started at 55, but it leveled out where it is right now for the last day and a half or so. Here's the current measurements. So we'll start with the output. Seems I'm on it already. So I'll go here with some of the strongest spikes. I'll measure that. That's 330 milliamps, and then I'll bring it up here. More of an average. Somewhere around there. 170 milliamps. So switch that to the input now. And do the same. Bring this in a bit. What's that? 500 milliamps, 50 millivolts. Right here. I'll bring it up. An average. Right, 320. And that's the input voltage. There's the output voltage, 58.41. Won't be long, I'll be turning on the big lights in here again where it's cooling off outside, so. So yeah, I've also got, let's see here. So I've got a couple of these here. I've already tested them. Like, when I test things, I usually bring them to failure. See where they fail at. This one has failed. I wanted to see what the real limits of the upper voltage. I think they say, I can't remember. I think it's 120 volts input with 20 amps output. And yeah, it does it. It's, I have it written down somewhere. It's over 130 volts where it fails at. This one's still a good one. I like to test stuff like that to know their limits. But yeah, these are really good. It's a buck converter. So I can take this power here from the 58 volts and convert it to current. Put it back into the battery. Like that. So I'm probably going to stop this here. And on the weekend, I'll probably transfer that power back into this battery. I don't have time right now to do it. It takes quite a long time because there's a lot of power stored up in that 1 volt difference here. It'd take about 7-8 hours to transfer it back into this battery. Because there's quite a bit of power stored up in this 6500 milliamp hours. And that's a conservative rating. At the lower draws on them, you're looking somewhere around 8 amp hours. So there's quite a bit of stored power in there. And to draw it down that whole volt takes quite a long time. Because to do it efficiently, you don't want to pull a lot of current out of them. You can get, like, I'm only putting in a small amount of power here. You could see like 320 milliamps or whatever it was, 300. The pulse is going into the battery, so to get the best efficiency, it's best just to transfer it slowly back into this one, which takes time. I'll have to do it on the weekend. Well, thanks for watching, guys. Just wanted to make this update, show you what I'm going to do here next. Probably going to use the buck converter. Pretty impressed with these. Yeah, that's what I've been working on with those solid state circuits that I have. I've been doing some of that, trying to figure out what is the best way to transfer the battery power back to input most efficiently. And, you know, like usable too, not just wasting it with a light bulb. But thanks for watching, guys. Really appreciate it. Hi guys, so I'm about to use this buck converter. Take the power that was put in here in these batteries from the motor here and put it back into the source battery. So this used to be the output, this was the input. Now it's going to be the opposite. Here's the voltage of this battery right here, 58.33. It started at 57.47, and I think that's what it was. And these batteries have been resting for 4 days now, since I turned the motor off. And it's bouncing at 13.3132. I think it was resting at 13.34 or 37. I can't remember, but it was somewhere around there before I turned the motor on with this battery. So I'm just going to transfer it with the buck converter. Put you guys on the tripod here for a bit. If I can. I don't have much room in here. I've not hooked it up yet with this one, so it might be a lot of current going in right off the bat. I'm not sure, but I'll adjust it. I want to try to make it so I'm putting about a steady 100 or 200 milliamps back into this into the like source battery. So I'll be ready with this to adjust it. Hook up the output first. If I can get all these on one clip would be nice. Still got that now. Get this one in here to the positive. input here now. As soon as it gets in there, it'll be turning on. Fans on. Yeah, 3.4 amps. This isn't very accurate. Try to put it to about 500 milliamps. I haven't measured like one of it. This is either measuring the input current or the output. I think it's the input. Let's back in there. So, and it's powering the fan too, obviously. Power being wasted there. See, here's the voltages now. That's the source battery 13.4, and this is the what used to be the output 58.25. So let's see, I'm curious. I should be able to just leave that in there. Screwed that up. Maybe I've done these. I don't remember. There we go. $540 milliamps. Yeah, so that's reading the input current probably 310. See if I can get it on one of these. No, it's just off. 170 milliamps on the input. It's just that far off. This is an accurate meter, so I know that one's right. Try to leave this at one hand. There. 58.21, 1341. It's about 500 milliamps going in. It's a little more than I wanted, but should maybe turn it down a little bit. It's wasting quite a bit of power here in the fan. I should unplug the fan because this thing's rated for, I think, like 16 or 20 amps, I can't remember. But it's quite a bit. I know that. Turn that for a bit. Voltage in the battery went down a bit. Can't remember, I think it was resting at 13.34 or 37. But this is going to take a while, so I'll be back later. Okay guys, this is as far as I'm going to go. It's taken a really long time. I've got to be somewhere tonight. This has been going all afternoon. There's the battery voltage. This is these batteries voltage. And that's the source battery from when it was running the motor, but that's where the power is getting transferred to now. So unplug this. Leave it rest for a bit. So there's the battery voltage right now. I'm pretty sure it was 13.37 or 36. Actually, I'm not pretty sure. I'd have to look back at the previous video from when I started this motor with this battery. I know I think it was 13.34 when I added this battery. I did some testing with 4 cells instead of 3 here. Or I mean, 3 cells was this one instead of the 2 that's here now. And I'm pretty sure when I started the motor it was 13.34. Like after I wasted some of the power at 13.47 was with, or 37 I mean, was with this cell right here instead of this one. And I ran it for quite a while. Did some tuning with the changing frequencies and stuff. Did that for quite a few hours. And then I switched to 1 cell less, so I put this one in. And I know the voltage was 57.47 when I started with this configuration. So I could have went quite a bit longer sucking it down, but anyway, thanks for watching, guys.